Imagine stepping through, I don't know, a shimmering archway, maybe a portal, and boom. In an instant, you're not just across town or even across the world, but light years away, maybe on some distant exoplanet or who knows, another galaxy entirely.
So it's like pure science fiction, right? Straight out of a movie.
Exactly, like something ripped from, the wildest dreams of Hollywood writer or maybe a classic space opera novel. Well, today on the deep dive, we're actually going to challenge that. We're going to really dive into it. We're plunging into a truly groundbreaking and honestly kind of mind-bending scientific paper from 2024. It's by Philip Randolph Lilien, and it's simply titled Hyperwormhole Stargate Technology.
That's right. And our mission today really is to take this incredibly complex, dense, deeply theoretical material. I mean, this paper sits right at the cutting edge of what we even think might be possible in physics. And we're going to unpack it for you. We'll try to distill the core sort of revolutionary ideas, break down the really sophisticated concepts, and reveal how this radical new framework proposes to make something that seems utterly impossible. Well, not just conceptually viable, but actually mathematically feasible. So the goal for you listening right now is to walk away from this deep dive, not just informed, but maybe seeing the universe through a slightly new lens, understanding a possibility that could, well, fundamentally redefine our grasp of the cosmos and maybe our place in it.
And what makes this deep dive, I think, particularly interesting, so focused, is that we're mostly looking at just one source.
Yeah.
But it's incredibly comprehensive.
Right. It's not like we're juggling a dozen different conflicting papers here.
Exactly. It's one cohesive, rigorously presented paper. It lays out the theoretical foundations, digs deep into the technical requirements, and get this, even proposes a concrete step-by-step experimental path for these technologies.
It's almost like getting a direct download from the absolute bleeding edge of theoretical physics.
Yeah, offering this unified vision of how stargates might one day actually move from pure fantasy to, well, breathtaking reality. It's a single theory for something people have imagined for, like, ever. Okay, let's try and unpack this, because it really takes a bit of a shift in thinking. Most of us, we've heard of wormholes.
Yeah, they pop up everywhere. Sci-fi loves them.
Exactly. Movies, books, these sort of theoretical shortcuts through space-time. They're fascinating, absolutely. But there's always been this huge problem, hasn't there? A kind of cosmic Achilles heel with them in traditional physics.
Oh, definitely. A massive one.
What is that big hurdle? The fundamental barrier that's kind of kept wormholes stuck in the realm of pure speculation?
The biggest hurdle, and it really is colossal, is something physicists call exotic matter. See, in the standard wormhole theories, especially the ones based on Einstein's general relativity, his theory of gravity, you need something really weird to keep the wormhole's throat stable, to keep it open for passage.
Okay.
And that weird thing is matter, or energy, with negative energy density. Now, just let that sink in for a sec. Everything we know, every particle, you, me, the stars, all the energy we see,
Yeah.
it all has positive energy density.
Right. Positive mass, positive energy. It pulls space-time inwards, kind of.
Exactly. Curves it in a certain way. Exotic matter with negative energy density would do the opposite. It would push space-time apart, essentially propping the wormhole open, stopping it from collapsing instantly.
But the catch is...
The catch is, we've never found any. And many physicists think it might be impossible to create in large enough amounts, if it's even possible at all. It's this huge theoretical roadblock, and a massive practical one, too. It basically means traditional wormholes, the Einstein-Rosen bridge type, would just pinch off immediately. Useless for travel. So, this raises a really important question for you listening. What if there's another way, a completely different approach that just sidesteps this whole exotic matter problem?
And that's exactly where this paper, Lillien's paper, brings in this radical solution. Hypergravity. Now, when I hear hypergravity, I just think, super strong gravity, like spinning really fast in a centrifuge.
Right, like astronaut training.
Yeah. But that's not quite it here, is it? It's something much more fundamental. What exactly is hypergravity in this context? And crucially, how does it get around eating that weird exotic matter?
You're spot on. It's much more subtle than just cranking up gravity.
Yeah.
In Lillien's model, hypergravity isn't a conventional force like planetary pull. Instead, it's described as a direct manifestation of something he calls higher dimensional coherent resonance fields.
Okay. Higher dimensional coherent resonance fields. That's a mouthful. Break that down.
Let's try. The key words are higher dimensional and perfect coherence. Higher dimensional means it's operating in dimensions beyond our familiar three-spatial and one-time dimension, and perfect coherence. Think of it less like a force and more like a state of absolute fundamental harmony. Like, imagine a laser beam, how all the light waves are perfectly aligned,
Okay, yeah.
in sync.
Kind of like that, but way more fundamental. Applied to the very fields that might underpin reality itself. It's the state of perfect synchronized resonance, but across these extra unseen dimensions.
And that coherence is what stabilizes the wormhole. Exactly. That property, perfect coherence, is what allows hypergravity to stabilize a wormhole structure in this higher dimensional space without needing any exotic matter. Mathematically, it modifies the Einstein-Rosen bridge equations, instead of a term needing negative energy density to keep the throat open. Lilien's framework substitutes this property of the coherence field itself. It changes how energy and momentum warp space-time in that specific region, creating stability where standard physics predicts collapse.
So the stability comes from the coherence itself, not from pushing space apart with negative energy.
Precisely. It's a self-sustaining stability born from the nature of these perfectly coherent higher dimensional fields.
Okay, this is where my brain starts to stretch a bit. Hyperdimensional wormholes. We're so used to thinking in 4D length, width, height, time. What does it even mean for a wormhole to exist beyond that, to operate outside our perceived reality?
Yeah, you really have to let go of everyday intuition here. These aren't tunnels through our familiar four dimensions. Think of them more as existing as hyperdimensional structures themselves, like a fold or a connection point that exists in a higher, more fundamental layer of reality, which our 4D spacetime is just maybe embedded within.
Like our universe is just a surface on something bigger.
Sort of. That's one way to visualize it, though analogies always break down. The point is, their existence in these higher dimensions is what lets them bypass the rules we take for granted. Rules like the vast distances between stars, or even the seemingly fixed progression of time. They operate where our 4D constraints just don't apply in the same way.
Which allows for these incredible shortcuts.
Exactly. Shortcuts that are simply impossible if you're confined to our four dimensions.
Okay, following that thread, the paper then introduces the hyperfractal universe. Wow, that sounds complex. Like some kind of cosmic Mandelbrot set making up reality.
Yeah, it does have that vibe, doesn't it? But yeah, the idea is that space-time itself isn't fundamental. It's not the bedrock.
It's emergent. It arises from something deeper.
Exactly. It emerges from these hypersymmetry, hyperspace conditions, as Lilien calls them.
Yeah.
And this deeper reality has a hyperfractal nature.
Meaning like repeating patterns across scales.
Yes, precisely. Imagine space-time isn't a smooth sheet, but composed of intricate, self-similar patterns of resonance conduits at all scales, from the quantum foam up to cosmic structures. These conduits connect points in our 4D space by aligning coherence nodal points in that higher dimensional space.
Okay, let's try that paper analogy again, folding the paper.
Right. Imagine a huge piece of paper, our 4D universe. 2 points are far apart on the surface. The normal shortest path is a line across the paper.
The geodesic.
Right. But if you fold the paper in higher dimensions so those points touch, the shortest path isn't across the surface anymore. It's through the fold. Instantaneous almost.
So the hyperfractal structure is the folds.
In a way, yes. The resonance conduits are the pathways through these folds. The shortest path, the geodesic, becomes a hypergeodesic that cuts through these higher dimensions via the aligned coherence points. So the effective distance from the perspective of traveling that hypergeodesic becomes effectively zero or incredibly close to it.
Wow, so light years become nothing.
Essentially, yes. You're not traveling the distance in 4D space. You're bypassing it through a higher dimensional shortcut provided by this hyperfractal structure. So think about this. How fundamentally would that change your perception of distance, of travel? If that were real, it completely rewrites the map.
It really does. It's an absolutely astonishing conceptual leap. Okay, so if this is theoretically possible, if space can be folded like that, the next big question is mechanics. How do we use it? How would a Stargate, as Lilien describes it, actually function within this whole hypergravity, hyperfractal thing? What's the proposed process for making that instantaneous jump happen?
All right, moving from the what to the how. The paper lays out a process for establishing a Stargate connection, and it's fascinatingly precise, even theoretically. It starts by creating what's called a resonance pathway between two potentially incredibly distant points.
So not just opening a door, but tuning something.
Exactly. It's about meticulously tuning the fabric of space-time itself. You'd use a device called a resonance field operator. Think of it as a highly sophisticated tuner. This operator adjusts the frequencies and phases of those coherence fields we talked about at both the starting point and the target point, getting them perfectly aligned, perfectly in sync.
Like hitting the exact same note on two instruments light years apart.
A pretty good analogy, yeah.
Yeah.
But this alignment does more than just connect them. It actually temporarily restructures the local topology, the very shape of space at both ends. This restructuring creates a stable, traversable passageway between those two synchronized points. It's like making two distant bubbles of spacetime vibrate in perfect harmony, allowing them to momentarily touch and form a bridge.
Okay, so you create the pathway through resonance, but then the age-old wormhole problem, keeping it open. Normal wormholes collapse instantly. How does the system stay stable? What stops this hyperdimensional tunnel from just vanishing?
And that's where hypergravity is the absolute key. The paper really hammers this home. The coherence fields are the stabilizing mechanism. Remember, traditional wormholes need that hypothetical exotic matter with negative energy density to push outward against collapse.
Right, the stuff we don't have.
Exactly. But here, hypergravity itself, arising from that state of perfect coherence, provides the stability. It inherently prevents the Stargate structure from collapsing. To be really clear, hypergravity isn't just acting on the coherence field, it is the manifestation of that field across higher dimensions. By generating and maintaining this perfect coherence in those specific spots, hypergravity intrinsically creates and holds open that stable throat, the channel you can travel through.
So the need for exotic matter just evaporates.
Completely. It's replaced by a property of the coherence field itself, a property rooted in the theory's higher dimensional physics. It's self-stabilizing.
This feels like it changes everything about how we think about physics, especially travel. If we can manipulate these fields, create stable tunnels, what does that do to space and time? How does this manipulation of coherence and hypergravity actually achieve these impossible shortcuts? It still feels like it's breaking the rules of distance.
It kind of is breaking our perceived rules. This gets to the core idea. Rewriting space-time topology. It's not like a warp drive which tries to bend space around a ship. This is more fundamental.
How so?
By altering the resonance of these coherence fields, the system doesn't just bend the geodesics, the normal shortest paths in our 4D space. It literally restructures the local geometry. It rewrites the map locally. This allows travel through what the paper calls non-Euclidean pathways. Basically, the normal rules of straight lines and distances in 3D space don't apply within that pathway.
Because the shortest path isn't in our dimensions anymore.
Exactly. The shortest path becomes that hypergeodesic through higher dimensional space. So, from the perspective of someone or something in that pathway, the effective distance between the start and end points becomes zero, or vanishingly small.
So it feels instantaneous.
It would be effectively instantaneous from an external 4D perspective. You're not crossing the intervening space. You're bypassing it entirely through this temporarily rewritten topology.
Yeah.
You're taking a shortcut that isn't located within our normal space.
And you mentioned earlier, this isn't like punching a permanent hole in the universe. The paper talks about dynamic conduit formation. That sounds important.
It's crucial, yeah. This isn't a static portal. The resonance coil conduit, the actual channel, is formed dynamically. It adjusts the topology in real time.
Meaning you can switch it on and off?
Precisely. It can be created for a specific trip, maintained just long enough for passage, whether it's a ship, information, whatever, and then closed down.
That seems much safer and more efficient than a permanent hole.
Absolutely. It's flexible, adaptable. You create the connection when needed, where needed. It allows for much greater precision, control, energy management, and inherent safety compared to some static wormhole concepts. It's like an on-demand cosmic subway system rather than a permanent open tunnel.
Okay, the idea of instantaneous travel is already staggering. Hard to fully wrap your head around it. But this framework, as Lilien lays it out, it goes way beyond just getting from A to B faster. It seems to poke at the very nature of reality itself. If space and time aren't the fundamental stage, but are emergent phenomena, arising from these deeper hypersymmetry and coherence conditions, what does that really mean? What's the biggest philosophical takeaway here?
That's maybe the most profound part, the so what, beyond the engineering. If space and time are emergent, it implies there's a deeper layer of reality, this hyperspace, governed by coherence and resonance from which our familiar 4D world unfolds. It's like realizing the image on your screen isn't fundamental. It emerges from the code, the pixels, the hardware beneath.
So our universe is like the display.
In a sense, yeah. It challenges everything, and it reframes things like causality. Even with these non-local instantaneous connections, the framework suggests causality is preserved. The connections are governed by the rules of this higher dimensional hyperspace, the resonance conditions, which maintain the relationship between space and time consistently across all dimensions. No paradoxes, theoretically.
So cause still comes before effect, even with instantaneous jumps.
According to the theory, yes, the coherence framework ensures it. It suggests a universe far more interconnected, maybe more malleable, and fundamentally unified than we usually think. It forces you to ask, if space and time aren't the bottom layer, what is? And if we can tweak them, what else might be adjustable?
Okay, so if we can redefine space and time like this, manipulate the very canvas, what are some of the really wild applications beyond just getting spaceships around? Let's start with communication. Our signals are limited by light speed. Could this change that?
Oh, absolutely. Dramatically. The same principles, hyperdimensional geodesics, resonance fields, could revolutionize communication. Think instantaneous, galaxy-spanning networks. Right now, quantum communication relies on things like entanglement, but quantum coherence is incredibly fragile. It breaks down over distance.
Decoherence, right.
Exactly. Makes long-range quantum communication super difficult. You need complex repeaters. But by using these hypergravity-enhanced coherence fields, you could potentially overcome that fragility barrier. Stargates could act as robust quantum relays, enhancing and extending entanglement over vast cosmic distances, maybe without needing physical repeaters at all.
Creating a galactic quantum internet.
Potentially, yes.
Yeah.
A quantum internet that spans galaxies, allowing secure, instantaneous information flow. And it goes further, maybe even stabilizing quantum teleportation protocols, transferring quantum states instantly across Stargate connections. Secure, faster-than-light communication becomes feasible.
Wow. Okay, an instantaneous galactic internet. That's huge. What about energy? Could Stargates tap into some new source, maybe solve our energy problems?
That's another major potential application. The paper integrates principles of zero-point energy, or ZPE, with the hypergravity framework. ZPE is the energy inherent in the quantum vacuum, the empty space around us. Usually, it's considered inaccessible.
The energy of empty space itself.
Right. But the theory suggests that Stargates, operating in this hyperdimensional context, could make vacuum energy much more accessible. By carefully stabilizing and amplifying ZPE fields within the Stargate's resonance conduit, you could potentially tap into the quantum vacuum for a near-limitless energy source.
How? Like pulling energy out of nothing?
Not quite nothing. It involves manipulating quantum fields, maybe converting virtual particles, those fleeting particle-antiparticle pairs that pop in and out of existence, into real, usable energy. So Stargates wouldn't just be travel points. They could become interdimensional energy distribution hubs.
Supplying clean energy anywhere on the network.
Exactly. Vast amounts of clean, sustainable energy drawn from the fabric of reality itself, distributed instantly across the network.
Yeah.
It could mean the end of energy scarcity.
Okay, communication, energy. Now, for the one that always comes up, the really mind-bending one, time travel. Is that actually part of this picture or still just pure fiction?
Well, given that the framework treats time and space as unified and emergent, manipulating the resonance conditions could theoretically lead to temporal displacement.
Meaning travel through time?
Potentially, yes. Travel to different points in time, maybe forward, maybe even backward. The paper mentions the theoretical possibility of creating closed time-like curves, or CTCs.
Those loops in time that sci-fi loves.
Right.
Where you can meet yourself.
Right. Pathways in space-time that loop back, allowing travel to one's own past. But, and this is but the paper stresses that absolute coherent stability would be essential. Perfect stability.
To avoid paradoxes.
Precisely. Without perfect coherence, any temporal jump could unravel causality. So while it's conceptually possible within the model, the practical hurdles to ensure stability and prevent paradoxes are monumental, possibly insurmountable. It's on the table, theoretically, but with massive asterisks.
Okay, so instantaneous galactic travel, communication, limitless energy, maybe even time travel. The sheer scale of this technology feels civilization-altering, like Kardashev scale stuff.
Absolutely. If mastered, it could easily push humanity towards becoming a Type 3 Kardashev civilization, one that harnesses the energy of an entire galaxy. Connecting star systems, even galaxies, creates a cosmic network of civilizations. Imagine the exchange of resources, knowledge, culture.
And what about building things? Megastructures.
That's where stellar and planetary engineering comes in. If you can transport vast amounts of matter and energy instantly, think big. Building Dyson spheres around stars, easy transport of materials, terraforming planets, moving atmospheres, water, resources becomes feasible, constructing artificial habitats. All possible.
It changes the logistics of everything on a cosmic scale.
Fundamentally, it moves us from being planet-bound or even system-bound to being a truly galactic, maybe intergalactic species.
One last thing on applications. How does this fit with other FTL ideas like warp drives? Are they competitors or could they work together?
That's a really interesting point in the paper. It suggests the same coherence resonance principles could actually enhance warp drive concepts.
So improve them.
Yeah. Warp drives, theoretically, work by bending space around a ship. They still have energy issues and often rely on exotic matter concepts, too. But Lilien suggests that incorporating these hyperfractal resonance terms into the warp bubble physics could make them more stable, more energy efficient, maybe less disruptive to surrounding space.
So you could have both, a hybrid system.
Exactly, a hybrid drive system. Ships might use enhanced warp drives for, say, faster-than-light travel within a star system, or to nearby stars, more localized FTL.
And use Stargates for the really big jumps.
Precisely. Warp for tactical regional FTL, but Stargates for instantaneous long-haul travel across the galaxy, or between galaxies, the best of both worlds. So think about that. How would a future with both capabilities change everything for humanity, for our place out there? It's a future almost beyond imagining.
That vision, it's incredible. A future where humanity is truly cosmic. But, let's be real, it also sounds incredibly ambitious, almost fantastical. These are huge ideas, pushing physics and engineering to their absolute limits, maybe beyond. So let's ground ourselves again. What are the actual concrete challenges, the things we'd need to overcome to build any of this? What are the biggest roadblocks between the theory and a working Stargate?
You're right, we need that reality check. And the paper is clear. The technological requirements are staggering. We're not talking small steps here. We're talking entirely new fields of science and engineering, just to start.
Yeah.
We need things that don't exist yet.
Yeah.
Coherence field generators, devices capable of creating and sustaining these incredibly precise resonance conditions. We'd need resonance coil conduit structures that can actively modulate space-time topology in real time within hyperspace. And we need hypergravity control mechanisms, ways to manipulate higher dimensional space with unbelievable accuracy. These aren't just better versions of current tech. They're completely new categories.
Okay, let's drill down. What's the single biggest engineering hurdle? My guess is power. Manipulating space-time sounds like it needs insane amounts of energy.
Your guess is spot on. The number one challenge is likely high-energy field generation and control.
Yeah.
The sheer energy needed to create hypergravity fields strong enough to locally curve space-time and stabilize these hyperdimensional pathways. It's just astronomical. Orders of magnitude beyond anything we can currently manage.
So where would that energy come from?
Well, it would demand massive breakthroughs in things like zero-point energy, ZPE extraction, actually tapping the quantum vacuum for power, not just theoretically, but practically on a huge scale. And we'd need new devices, hypergravity wave emitters capable of generating controlled high-frequency gravitational waves far, far stronger than anything we've even detected, let alone produced.
And controlling that much energy.
Exactly. Just storing, managing, and precisely controlling that kind of power without it dissipating or cause, catastrophic failure is an immense challenge in itself. It's energy engineering on a scale we can't comprehend yet.
Okay, energy is one massive hurdle. What about the quantum side? We know quantum states are incredibly fragile. Decoherence happens easily. How on earth do you keep these delicate quantum coherence fields stable, especially within the intense dynamic environment of a working Stargate?
That's arguably the other number one challenge, quantum coherence stabilization. It's a monster of a problem. Maintaining quantum coherence perfectly over potentially vast distances and long durations inside powerful fluctuating gravitational fields. It's incredibly difficult, even in pristine lab conditions today.
So what's the proposed solution?
It would require revolutionary tech. Things like quantum coherence stabilizers, completely new devices or methods, and incredibly fast, precise feedback loops, constantly monitoring and correcting for decoherence in real time. We'd likely need to adapt cutting-edge ideas from quantum computing, maybe principles from topological quantum computers, which have some built-in error resistance, or highly advanced quantum error correction codes running constantly.
So it's an active, ongoing battle to maintain the coherence.
Absolutely. A continuous fight against the universe's tendency towards decoherence, requiring unimaginable levels of real-time monitoring and control over quantum states.
Okay, energy, quantum coherence. What about the physical stuff, the materials? What do you build these Stargate components out of? Surely normal materials would just disintegrate.
You're right. Standard materials wouldn't stand a chance. We're talking about needing a revolution in material science. We'd need things like high-strength superconductors, probably operating at room temperature to be practical, capable of handling immense currents and generating incredibly stable magnetic fields needed for the resonance. And beyond that, specialized hypergravity-resistant alloys, materials engineered at the atomic level to withstand extreme gravitational stress, intense fields, rapid temperature changes.
Things that don't exist yet.
Not even close. The paper suggests looking towards advanced nanomaterials and metamaterials. Materials designed with specific, maybe even adaptive properties, resistance to extreme forces, incredible strength, maybe even ways to interact with the hypergravity fields themselves. It's about inventing entirely new classes of matter.
And assuming you could build it, how do you navigate? If you're jumping through higher dimensions, how does the ship or the system know where it's going? There's no GPS in hyperspace.
Another critical challenge: hyperdimensional navigation and control systems. Our current navigation is purely 4D, operating in this constantly reconfiguring hyperfractal topology. It would require a completely new form of coordinate system, something that can map and understand this complex higher dimensional structure in real time.
Which sounds like a job for AI, or something even more advanced.
Definitely. We'd need incredibly powerful AI, maybe even quantum computers, just to process the topological data and integrate it with the controls. The paper speculates about things like holographic control interfaces, ways to visually represent these higher dimensions so pilots could see the pathways, or even direct brain-computer interfaces, BCIs, allowing instantaneous, intuitive control over the resonance fields. It's rethinking navigation from the ground up.
So when you put all these challenges together, energy, coherence, materials, navigation, what's the big picture takeaway on manipulating hypergravity?
The big picture is that mastering this wouldn't just give us stargates. The underlying principles controlling gravity beyond known limits, manipulating quantum coherence at will, they represent a scale of transformation that's almost total. It could revolutionize propulsion, energy, maybe even medicine. The paper hints at things like aging reversal through fundamental manipulation. Advanced computing, too. It's not just one technology, it's unlocking a new layer of physics that would fundamentally change the entire landscape of human technological progress. It's a different future entirely.
It really does sound like a different future, almost unimaginable. But here's what's maybe most fascinating about Lilien's paper. It doesn't just leave it at grand theory. It actually lays out a potential path, starting now or soon, to experimentally test some of these core concepts in a lab. How do you even begin to experiment with creating a portal, even a tiny one? What's the very first step to bridge that huge gap between theory and actual measurable results?
That's right. It proposes an initial experimental setup for small-scale portal technology test. It's a very methodical, step-by-step approach. The idea is to start incredibly small, focus on validating the key underlying principles one by one. Can we actually manipulate coherence like this? Can we induce tiny curvature changes? Can we harness energy from the process? It's not about building a working transporter right away. It's about proving the fundamental physics and engineering concepts are sound in a controlled lab setting, building the foundation.
Okay, so what are those very first foundational tests? How do you even approach manipulating quantum fields in spacetime in a lab? It sounds incredibly delicate.
The absolute starting point proposed is the quantum coherence modulation test. The goal here is simply to develop and prove we can precisely control the coherence of quantum fields around specific particles, say electrons or photons.
Just keeping them stable under certain conditions.
Exactly. Making sure they can maintain their quantum state, resist decoherence, under the kinds of conditions you'd expect just before a theoretical dimensional transition. You'd use a device called a quantum field modulator to exert that fine control. Success means showing you can reliably maintain coherence under stress, proving that basic quantum manipulation is feasible. That's step one.
Makes sense. If you can keep the quantum state stable, then you need to actually try and, well, bend reality a tiny bit. How do they propose doing that? Inducing space-time curvature in a lab sounds hard, maybe impossible to measure.
It's definitely pushing the boundaries of measurement. That leads to the curvature manipulation test. Here, the aim is to use a different device, a curvature modulator, to create tiny but controlled and detectable deviations in the local space-time geometry.
Like making microscopic dents in space-time.
Sort of, yeah. Manipulating the local metric tensor. You'd need incredibly sensitive instruments, like advanced laser interferometers, far more precise than usual, to even detect these minute distortions. Success here is just demonstrating smooth, controllable, stable changes in local curvature, proving the principle that space-time geometry can be locally manipulated as the theory predicts, even if only slightly.
Wow. Okay, coherence control, curvature control. Is there any immediate payoff in these early tests, like maybe an energy aspect?
Yes, interestingly there is. The third proposed test is quantum sealed interaction and energy recycling. This looks at whether you can actually harness some energy from the quantum fluctuations, the vacuum energy, or quantum noise that the theory predicts would occur during these state transitions. They propose using an energy harvester device integrated into the setup to capture these tiny amounts of energy directly from the quantum vacuum interactions.
To power the experiment itself.
Ideally, yes. To see how much energy can be recycled back into the system, potentially reducing the overall power needed. It's a crucial step towards making the whole concept more energy efficient and maybe eventually practical.
So you put all these together, coherence, curvature, energy recycling. What's the ultimate goal of combining them in these initial stages? What does a successful small-scale portal test actually achieve?
The culmination is the small-scale portal creation test. This is where you integrate all those pieces. The coherence modulator, the curvature modulator, the energy harvester working together. The objective isn't to send anything big, but to create a tiny localized region where information, or maybe individual particles, can demonstrably transition across space in a way that simulates that higher dimensional jump.
And success means?
Success is defined very strictly. Particles must make the transition without losing coherence if their quantum state stays intact. They must pass through without hitting destabilizing curvature effects. The passage is smooth. And the energy recycling system must show a measurable reduction in the net energy cost.
So proving the whole mechanism works, in principle, on a micro scale.
Exactly. It's the fundamental proof of concept, showing the physics holds up and can be engineered, even if only for subatomic particles in a lab. That would be a monumental breakthrough.
It really would. But maintaining stability across all that, coherence, curvature, it sounds incredibly fragile. How do they propose keeping it all stable during the test? What stops it from just fizzling out or going wrong?
Stability is the absolute linchpin, and the paper emphasizes continuous refinement of modulation algorithms and extremely sophisticated feedback systems. This isn't a static experiment. It requires constant, real-time quantum feedback control and predictive algorithms, probably using advanced machine learning running alongside.
Predictive to anticipate problems.
Yes. To constantly monitor the coherence fields, the curvature pulses, predict potential instabilities or decoherence before they happen, and make micro-adjustments preemptively. The paper mentions borrowing techniques from quantum computing again, things like dynamical decoupling, using pulses to cancel out noise, or maybe leveraging the quantum Zeno effect, where frequent measurement can freeze a quantum state.
So it's an active, intelligent control system fighting entropy in real time.
Precisely. A dynamic, relentless process to maintain that delicate balance needed for the transition.
Okay, so let's say these incredibly complex small-scale tests actually work. We get proof of concept. What's the next logical step? How do you get from tiny particle transitions to something, well, bigger?
The progression outlined is careful and iterative. After the initial proof of concept, you'd move to initial scaling tests. Maybe operating the system at, say, 50% or 75% of what might be considered full theoretical capacity for a slightly larger system. The goal here is to prove the principles scale up, handling more particles, larger information streams, higher field intensities.
Making sure it's not just a microscopic fluke.
Exactly. Proving scalability. This involves significant engineering to build bigger, more powerful field generators and conduits. And if that works, the final phase before trying anything truly large-scale would be full-scale testing of a prototype portal generator, maybe running at 100% design capacity, but over extended durations, 12 hours, 24 hours, maybe longer.
Really stress testing it.
Right.
Validating the scalability, the energy efficiency, the robustness under demanding near-operational conditions. Lots of calibration, monitoring, identifying, and fixing the inevitable engineering challenges that crop up when you scale technology like this. It's a long, careful road from lab bench to anything resembling a practical device. Hashtag outro. But, the successful full-scale test of even one of these small-scale portal prototypes, if we can genuinely show we can manipulate space-time and quantum coherence in these fundamental ways, it just opens up possibilities that are truly astonishing. It really does redefine our whole understanding of the universe and what might be achievable within it. If we can learn to control the fabric of existence like that, well, it changes the game entirely.
Yeah, it really does, and it leaves you with this thought. If space and time really are emergent, if they arise from something deeper, and we can actually learn to manipulate that deeper level, to rewrite the topology, then what other aspects of our reality, things we currently think of as fundamental, unchangeable laws, might also be emergent, might also be open to redefinition someday? That's the big question, isn't it?
It is. It's a really profound question, one that could genuinely shift our understanding of the universe forever. It invites us to imagine possibilities that right now maybe seem impossible and to rethink our place in the cosmos. Well, we hope this deep dive into Philip Randolph Lilien's incredibly ambitious paper, Hyperwormhole Stargate Technology, has given you maybe a glimpse into one possible revolutionary future, a future where science fiction might just become science fact. We definitely encourage you to continue your own exploration of these mind-bending concepts. Until next time on The Deep Dive, keep digging deeper.